Let's see if we can stumble our way to another logarithm property. So let's say that, oh, I don't know. Let's say that the log base x of a is equal to b. Right? That's the same thing as saying, that is the exact same thing as saying that x to the b is equal to a. Fair enough. So what I want to do is experiment. What happens if I multiply this expression by another variable? Let's call it c, right? So I'm going to multiply both sides of this equation times c. And I'm going to switch colors just to keep things interesting. That's not an x, that's a c. I should probably just do a dot instead. Times c, right? So I'm going to multiply both sides of this equation times c. So I get c times log base x of a is equal to, multiply both sides of the equation, right? Is equal to b times c. Fair enough. I think you realize I have not done anything profound just yet. But let's go back. We said that this is the same thing as this. So let's experiment with something. Let's raise this side to the power c. So I'm going to raise this side to the power c. That's a kind of a caret. And when you type exponents, that's what you would use, a caret, right? So I'm going to raise it to the power c. So then this side is x to the b to the c power is equal to a to the c, right? All I did is I raised both sides of this equation to the c power. And what do we know about when you raise something to an exponent and you raise that whole thing to another exponent? What happens to the exponents? Well, that's just an exponent rule, and you just multiply those two exponents. So this just implies that x to the bc is equal to a to the c. What can we do now? Well, I don't know. Let's take the logarithm of both sides, right? Or let's just write this. Let's not take the logarithm of both sides. Let's write this as a logarithm expression. We know that x to the bc is equal to a to the c. Well, that's the exact same thing as saying that the logarithm base x of a to the c, right? Logarithm base x of a to c is equal to bc. Correct? Because all I did is I rewrote this as a logarithm expression. And I think now you realize that something interesting has happened. That BC, this BC, well, of course it's the same thing as this BC, right? So this expression must be equal to this expression. And I think we have another logarithm property. That if I have some kind of coefficient in front of the logarithm, I'm multiplying the logarithm. So if I have c clog base x of a, but that's c times the logarithm base x of a, that equals the log base x of a to the c. So you could take this coefficient and instead make it an exponent on the term inside the logarithm. That is another logarithm property. So let's review what we know so far about logarithms. We know that if I write, let me use a different, let me say, if I write, well, let me just, the letters I've been using, c times logarithm base x of a is equal to logarithm base x of a to the c. We know that. And we just learned that logarithm base x of a plus logarithm base x of b is equal to the logarithm base x of a times b. Now let me ask you a question. What happens if instead of a positive sign here, we put a negative sign? Well, you could probably figure it out yourself, but we could do that same exact proof that we did in the beginning, but in this time we'll set it up with a negative. So if I said that, let's just say that log base x of a is equal to L. Let's say that log base x of b is equal to m. And let's say that let's say that log base x of a divided by b is equal to n, right? And how can we write all of these expressions as exponents? Well, this just says that x to the L is equal to a, right? Let me switch colors. That keeps it interesting. This is just saying that x to the m is equal to b. And this is just saying that x to the n is equal to a over b, right? So what can we do here? Well, what's another way of writing a over b? Well, that's just the same thing as writing x to the L, because that's a, x to the L over x to the m, that's b, right? And this we know from our exponent rules, right? It's this, you could write, this could also be written as x to the L, x to the negative m, right? Or that also equals x to the L minus m. So what do we know? We know that x to the n is equal to x to the L minus m, right? X to the n is equal to x to the L minus m. Those equal each other. I just made a big equal chain here. So we know that n is equal to L minus m. Well, what does that do for us? Well, what's another way of writing n? I'm going to do it up here, because I think we have stumbled upon another logarithm rule. What's another way of writing n? Well, I did it right here. This is another way of writing n, right? So logarithm base x of a over b, this is an x over here, is equal to L. L is this right here, right? Log base x of a is equal to L. The log base x of a minus m. I wrote m right here. That's log base x of b. Log base x of b. There you go. I probably didn't have to prove it. You could have probably tried it out with dividing it, putting a number, whatever. But you now are hopefully satisfied that we have this new logarithm property right there. Now I have one more logarithm property to show you, but I don't think I have time to show it in this video, so I will do it in the next video.